Let's look at another example of a two-sample t-test. A student asked to go off campus for lunch. The teacher replied, "Don't go to Wendy's. You always come back late if you go there. Go to McDonald's." The student thought that this was unfair, and she wanted to determine whether the wait time in the drive-thru at McDonald's was shorter than at Wendy's. She used a random sample of 30 cars at McDonald's and 27 cars at Wendy's and obtained the wait times listed, and those are measured in seconds. Is the McDonald's drive-thru faster? Use an alpha or significance level of 0.1. So we do have the data provided. It's on the tab Mickey D and Wendy's. And then the order of subtraction we're going to use is Mickey D minus Wendy's. So if you look in your notes, you'll see that you have the normal probability plot as well as the sample mean, standard deviation, and sample size for each group. Go ahead and pause the video and give this a try. All right, let's see how it went. So the P in phantoms is a statement about our parameter. So we're talking about the mean of one group versus the mean of the other group. So something along the lines of, we're testing the claim the mean wait time at McDonald's is shorter than the mean wait time at Wendy's. This will give hypotheses. A null hypothesis, mean at McDonald's minus the mean at Wendy's is equal to 0. So it means they're roughly equal. And then the alternative is that the mean, or mu, at McDonald's minus the mean at Wendy's is less than 0. That less than 0 is what's going to indicate that the Mickey D's is a faster drive-thru. Our assumptions and conditions, we'll start with the McDonald's group. So we do have a random sample, and that was stated in the problem. Our sample size is n equals 30, so the central limit theorem applies here, and we'll circle the word large. And then our sample standard deviation is s is equal to 39.61. And then for the Wendy's group, we do have a random sample for them as well that was stated in the problem. We're not quite close enough for the central limit theorem. We're at n equals 27. So when we look at that normal probability plot, it is a little bit bumpy, but that's okay because we are so close to that large sample size of 30. And then our sample standard deviation here is 102.85. So when I look at these two sets of assumptions and conditions, one thing that sticks out to me is that the standard deviation for McDonald's is about 40, and the standard deviation for Wendy's is almost 103. So much larger standard deviation for Wendy's, which means their data is going to be much more spread out, where the McDonald's data is going to be more compressed or more consistent. So it'll be interesting to see how this hypothesis test turns out. Now we do have two separate groups. These are independent groups. We have times for each car in the McDonald's list and times for each car in the Wendy's list. And those separate groups are what give us a two-sample t-test. For the test statistic, I got negative 4.06. And for the p-value, if I use the data analysis package, I got 0.0001. And if I use those Excel spreadsheet calculators that I built, I got 0.0002. So it's a commonly accepted practice in statistics that there is this more complicated formula. And so we use technology if we're wanting to be that precise. Otherwise, it is an acceptable practice to use that smaller of the two degrees of freedom between those groups. So either one of those would be fine. That's certainly much smaller than a 10% alpha, so we do reject. And our conclusion here is, with a p-value of 0.0001 at the 10% significance level, we do have sufficient evidence the mean drive-thru wait time at McDonald's is shorter than the mean drive-thru wait at Wendy's. All right, so let's take a look at these box plots, and I want to see these standard deviations. So based on those standard deviations, it makes a lot of sense why the McDonald's data is so nice and tightly consistent and compressed. And the Wendy's data is much more spread out. That's the difference between those standard deviations. And then if you remember from the box plots, those X's represent the means. So just visually looking at that, the mean between those two groups looks pretty far apart. So this matches what we found with the hypothesis test, that really there is a big enough difference here that the McDonald's is faster. All right, so if you feel comfortable with this, you're welcome to stop the video and go on to the next one. If you didn't get the same test statistic and p-value as me, I'll switch over to Excel and I'll show you how I got those ones. All right, so if you're wanting to use the data analysis package to get your test statistic and your p-value, you want to be on the Chapter 21 datasets on the Mickey D and Wendy's tab. So to do the data analysis, we do need to go to the data ribbon, and then we'll click on data analysis. And you're going to scroll down to the bottom of the list. What you're looking for is the two sample assuming unequal variances, meaning different standard deviations. We'll say okay, and then we'll highlight the Mickey D's data first, and then I'll highlight the Wendy's data, and I'll say okay. And so here's what we get as an output. Let me make this a little bit bigger. So our test statistic here, there's our negative 4.06 if you round that 9 over. And then our alternative hypothesis was a left tail, a less than. So that would be a one tail version. And that'll be the line right below. So that's where I got that 0.0001. Okay, and then if you hang on, I'll switch over to the Excel calculator spreadsheet that I built, and I'll show you that as well. All right, so on this, you're looking for the tab that says two sample t-test. And once you get there, you can put these numbers in from the guided notes. So for McDonald's, I had a mean of 133.6, standard deviation that was close to 40, and then that sample size of 30. And then in the other column, I put the Wendy's data. So it had a mean of 219.14, that standard deviation of 102.8, and then a sample size of 27. So you'll see I have the same test statistic, negative 4.06. And then this was a left tail test, and that's where I got that 0.0002. So either of those p-values would be just fine. The test statistic will always come out the same each time.